Hello, we're going to look today at elements and the periodic table. Our learning goals of today are that we should be able to identify whether an element is on the periodic table and whether it isn't, and we should have an idea of what makes up the atoms in each element. The periodic table is a summary of everything that is in the world. Everything in the world, every substance is made up of the things that you see on the periodic table. What makes chemistry interesting and exciting is that you cannot predict from just looking at the periodic table what your particular substance will be. For example, water consists of two atoms of hydrogen, here's hydrogen, joined to one atom of oxygen. Oxygen is a gas. We breathe it in, we can't see it, we can't smell it, but we definitely know if we weren't breathing it in because bad things would happen to us. Hydrogen is very reactive and will actually react with oxygen, and when they join together, they form water. Water looks nothing like hydrogen, water looks nothing like oxygen. So you can't say if I've got a particular substance and it's made of atoms joined together, that I can just look at the periodic table and just look at the atoms and say, well, as they're being joined together, the substance will be sort of halfway between hydrogen and oxygen. Hydrogen's a gas, oxygen's a gas, water is nothing like hydrogen or oxygen. So, in any substance we may find just one element, we may find lots of these elements joined together. I'd like you to think at the moment for things that you know around you, things that you've seen around you, and I'd like you to make yourself a little list. Pause the video now, and when you've made the list, come back. Okay, what's on your list? You'll have different things, but on my list, one of the things I'll write down is what we discussed before, water. So I'll get water written down on my list. I'll also get something that I know you find in electric lights, neon. I'm also going to write down in my list a few other terms. I'm going to write down things that cans are made out of, aluminium. So let's get aluminium written down. Sorry for my slightly bad writing. I'm also going to think of stuff I put on my chips, salt. Stuff that I should eat less of, sugar. Stuff that electric cables made out of copper. And finally on my list, I'm going to think of stuff that you make really strong building materials out of steel. So the question is, which of these things are elements on the periodic table? Which of these things just consist of one of these things on the periodic table? How would you solve a question like that? One of the easy ways is to actually go and explore what's on the periodic table. So what I do is I do a scan. So I'd start looking in. So let me go and do that. Start going looking, and I'll look for, say, aluminium. So I'd start on H, which is hydrogen. Hydrogen's not aluminium. So I go then to He, which is helium. Helium's not aluminium. I then go across to lithium, beryllium. That's not aluminium. I then go across to aluminium, silicon, phosphorus, sulfur, and bingo, I've found aluminium. So yes, I can say that aluminium is definitely an element on the periodic table. I found it, so I can say tick. So I'm going to now go and put a nice big tick for aluminium. Yes, aluminium is on the periodic table. Let's give it a nice tick. Then I'm going to go to my next element, or rather my next substance in my list, steel. Can I find steel anywhere? I'm going to go and have a look, and I'll look again. And no matter how I look, I can't find steel. So steel is not an element on the periodic table. Now you'll need to sort of satisfy yourself, you'll need to actually go and read, but you can go and read all these things, you won't find steel anywhere. So steel isn't. Put a cross next to steel, not on the periodic table. I can do the same thing for salt, and I won't find it anywhere. I can do the same thing for sugar, and I won't find it anywhere. Water I won't find anywhere. But when it gets to neon, I've got some good news for you. Neon is just one element, and you will see it on the periodic table. So I can put a tick next to neon. Let me go and do that now. Big tick. And finally, I get to copper. Now, copper is also on the periodic table, and copper is down here. What you'll notice about something like copper is that there are two things written on the periodic table. There's copper, which is the word for it, but underneath is a symbol for it, and it's a scientific shortcut. And for copper, the symbol is capital C and little u. If the symbols contain more than one letter, always the first letter is a capital, and the next letter is a small letter. So big C, little u for copper. You might think copper should be big C, little o, but in actual fact, big C, little o is used for cobalt over here. So you've got to be a little bit careful. Sometimes these symbols aren't obvious. If we go further down, silver is Ag. You would not expect silver to be Ag. You would not expect gold to be Au. We'll go back to copper. And we're going to start learning about what these various numbers mean. So, copper is got two numbers next to it. Write down, or just see if you can remember what those two numbers are. The first number tells us what element it is on the periodic table. First element on the periodic table, hydrogen, is element number 1, and then next element is element number 2. Where's 2? 2's the way all over here, and then I go 3, 4 on the left hand side, and then there's 3 and 4, and then I go right to 5, 6, 7, 8, 9, 10, etc., etc. So, the elements on the periodic table are numbered. Copper is number 29. Let's go back to copper. And this tells me what the atom is made up of. And it tells me that in the middle of the atom there are 29 things, and those things we call protons. If I had nickel, I'd have 28 protons. If I had an atom of zinc, I'd have 30 protons, but copper's got 29. The next number is a slightly trickier number, and the number below is not a nice number, and that's 63.546, and that tells me that a copper atom consists of 63.546 things that make it heavy. Now, we can't imagine easily a decimal, and the reason is the decimal is an approximation. Some atoms will be slightly heavier and have more stuff in, some atoms will be slightly lighter and they might have one bit of less stuff in it. But overall there's 63.546. For this year, what we're going to do is we're going to look at this number and we're going to round it up. So if I look at this number 63.56, whoops, and I round it up, it's actually going to be closer to 64. So I'll go and write 6. So this is really equal, or approximately equal to, if I pop this in, it's approximately equal to 64. And we're going to work with 64 rather than 63.56. It's closer to 64 than 63. And that tells us that all up the weight of the atom is 64. And it's made up of, therefore, extra things that give it the weight. So we've got that 29, what we call protons, and we've got a few extra things. So, in actual fact, if we were to draw this atom up, what we'd be doing is we'd be putting in the middle 29 protons. I'm gonna sort of draw a little diagram up here, and I'm going to write in the middle 29 protons. So in our atom, in the middle, there'll be 29 of these things called protons. Whoops. Let me just go and do this. There'd also be some extra numbers in here. And all up I know that the weight of my atom is 64. If it's 64, that means that there are extra things that make it heavy. So take 29 off 64. So in my little head, I do my calculation 64, and I take my 29 off, and I'm going to end up with another number. And if I take 30 off, I'd end up with 34. So take 29 off, which is one less, I'm going to end up with 35. So I've got 35 neutrons. And they're all in the middle of the atom. And around the outside, there are also 29 little things floating around, or I should really say whizzing around. And the 29 things that are whizzing around, we'll put little spots for all of them. There's one, 29 of them, all whizzing around. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. The things that are around the outside of the atom we call electrons. And there are therefore 29 electrons. In an atom, you'll always find if it's by itself and it's not joined to anything, the number of electrons will always be the same as the number of protons. Now I need to tell you about protons. Protons have a kind of electric force on it, and we say that the protons are positively charged. So we normally represent them with a little plus symbol to say they're positively charged. The electrons are the opposite charge, so they've also got an electric force associated with them, and they're the other way around. And they're on the outside. Slightly confusing that the negative things are on the outside, but that's how it is. And the neutrons have no charge in it, so we just draw them with so we might represent that with an empty circle. If you like, rather than draw it how I've drawn it, you can actually make your own little circles and start sketching the atom really, really well, putting in your 29 protons and your 35 neutrons and your 29 electrons. And that's all that an atom consists of. And outside of electrons and in the middle are the protons and the neutrons. I've done a bad job with this atom because I have not drawn it to scale. If I was drawing it to scale, the middle bit would be much smaller. And the other thing too is I've just put the electrons anywhere, but as you'll see if you move up to the core and beyond core levels, that they are arranged in a special way. They're not just scattered randomly throughout the outside of the atom, and they're arranged in what we call shells. Okay, so that's our thinking. And what I forgot to do, which I'll just do now, is we know copper is definitely an element, so we'll go and do a big tick for copper. So, in summary, if you want to find an element, go and look for its name on the periodic table. If you want to draw an element, you're going to have to start looking at these numbers and therefore working out how many protons, how many electrons, and how many neutrons. Remember, the protons is always that number. The electrons is the same number. And the neutrons is the extra bit that gives it its mass, its weight. And I think it's always easier to round off to the whole number. The reason why it's not a whole number is because not every copper atom's got 35. Some might have a slightly greater number. They might have 36 neutrons. Some might have 34. But on average, they've got 35 neutrons in them. Okay. Now, what you're able to do now, after watching this, is you'll be given a task to do, which you'll then be able to follow through, and that's going to make it easier for you. And we're going to start on the first few atoms. We're not going to go all the way to copper that's got big numbers. We'll actually start off with smaller numbers. If you want to watch that, feel free to watch that now.